All right, welcome back um, once again, my dearly beloved viewers and friends. This is Passwell Science Channel, and today we shall be solving likely uh, questions on NECO 2022 Chemistry Quantitative Analysis, otherwise known as titration. All right, so probably in another video I will show you how the actual titration is done in the lab and how I was able to obtain my titer values, as well as the uh, way manner I mean the way the reagents are prepared in the lab. All right, but for now let's look at some likely questions that may come out during the exams. So I hope you do enjoy the video. Please don't forget to like and subscribe to our channel, Passwell Science Channel. Do have a lovely day ahead. Thank you. All right, the question I have here says A is a solution of HNO3, that's triazonitrate 5 acid. B is a solution containing 1.05 gram of anhydrous sodium triisocarbonate 4 per 250 cm cube of solution. A. Put A into the burette and titrate it against 20 or 25 cm cube portions of B using methyl orange as indicator. Repeat the exercise to obtain consistent titers. Tabulate your readings and calculate the average volume of acid used. The equation for the reaction involved in the titration is, so you have sodium triisocarbonate 4 plus triazonitrate 5 acid reacting to give sodium triazonitrate 5, water and carbon 4 oxide. Alright, B says from your results and information provided, calculate the I concentration of B in mole per dm cube, II concentration of A in mole per dm cube, III concentration of A in gram per dm cube, and IV volume of the gas involved in the reaction at STP. The information we are provided include that hydrogen, atomic mass of hydrogen is 1, the relative atomic mass of carbon is 12, that of oxygen is 16, that of sodium is 23, that of nitrogen is 14, and the molar volume of a gas at STP is 22.4 dm cube per mole. So that these are the information that we are given from this particular question. All right, so let's go right straight into the solution. All right, so here I have my table already prepared. As I said before, I've already done the titration in the lab. Probably in a separate video I'm going to show us how I actually got my readings. So this is my table of readings. So you can see the volume of pipette is 25 cm cube. Indicator used is methyl orange according to what we are given. Then I have my burette reading, first titer, rough titer, first titer, second titer, and third titer. So that is my table, and from there I have that my average volume of acid used is the average of the first titer, second titer, and third titer, which is actually I think this divided by 3 here. All right, so we have 43.20 divided by 3, which will give us 14.40 cm cube. So that is my average volume of acid used. And then B says that we should calculate the concentration of B in mole per dm cube. Concentration of B in mole per dm cube is given by concentration of B in gram per dm cube all over molar mass of B. And for us to get the concentration of B in gram per dm cube, the formula is given by reacting mass times 1 dm cube or 1000 cm cube over volume used. And from the question, we have that the reacting mass is 1.05 gram, all right, per 250 cm cube. So the volume used is 250 cm cube, while the reacting mass is 1.05. So inputting those values, we are going to have that the concentration of B in gram per dm cube will be 1.05 gram times 1000 over 250, which will give us 4.20 gram per dm cube. Now the molar mass of B is sodium triisocarbonate 4, is obtained as shown here, 23 times 2 plus 12 times 6, plus 12 plus plus 12 plus, sorry, this plus here, yes. So we have 23 times 2 plus 12 plus 16 times 3, which will give us 106 gram per mole. Therefore, the concentration of B in mole per dm cube will now be 4.20 over 106, which will give us 0.0396 mole per dm cube. So that will be our CB, or concentration of B in mole per dm cube. And then the next question says that we should calculate the concentration of A in mole per dm cube. For us to do that, we have to write the equation of the reaction, a balanced equation. And from that equation, we have that the mole ratio of the acid to the base is 2:1. So using the mole ratio formula, CAVA over CBVB is equal to NA over NB, we have that our CB is 0.0396 mole per dm cube, already obtained. Our NA is 2. Our VA is 14.40 cm cube. Our VB is 25.00 cm cube. That is the volume of the pipette. Our NB is equal to 1. Then we are looking for the CA, that is the concentration of the acid. So substituting all of that into the mole ratio formula, we have that CA times 14.40 all over 0.0396 times 25.00 is equal to 2/1. And when you work that out, you have that CB is equal to 0.183 mole per dm cube. Ca is equal to 0.138 mole per dm cube. Then the next question says concentration of A in gram per dm cube. Concentration of A in gram per dm cube, what we call mass concentration, and that is given by the molar concentration in mole per dm cube times the molar mass of A. The molar mass of A, of course, that is triisonitrate 5 acid, is equal to, you can see it there, 63 gram per mole. Therefore, the concentration of A in gram per dm cube will be 0.138 times 63, and that will give us 8.69 gram per dm cube. Give us 8.69 gram per dm cube. And finally, the last question says the volume of the gas evolved at STP. Of course, from the equation of the reaction, the gas evolved is carbon 4 oxide, and we have just one volume of that gas. Just one volume of that gas evolved. So since one volume of that gas is evolved at STP, it simply means that the volume of the gas will be equal to the volume of the gas that is obtained at STP, which is 22.4 dm cube per mole. So 1 mole of any gas, or 1 volume of any gas, we have a volume of 22.4 dm cube at STP. So therefore, the volume of the 1 mole of carbon 4 oxide that is evolved during this reaction will be equal to 22.4 dm cube. So that is that for the quantitative analysis. All right, thank you very much for watching. Remember to subscribe to our channel and like this video. Give us a thumbs up. This is still Passwell Science Channel. Have a very productive day ahead. Thank you.